Good afternoon, everyone. I extend a warm welcome to all the participants to day 3 of the 6-day faculty development program on intelligent computing technologies organized by the Department of Computer Science and Engineering, Sripati Institute of Management and Technology. I hope everyone had an enriched experience in the previous sections. Today, we continue with two insightful sections focusing on data engineering, intelligent infrastructures, and data security. Without further delay, let us begin today's first technical section. It's my pleasure to introduce our first resource persons for today's section, Mr. Raghu Raman A V. Mr. Raghu Raman A V is a data engineering and big data consultant, mentor, and Udemy instructor with expertise in Databricks, AWS, Microsoft Azure, and Google Cloud Platform. He has extensive experience in designing and implementing modern data engineering solutions and mentoring professionals in emerging technologies. Today's section is titled Data Engineering and Intelligent Infrastructure. On behalf of the Department of Computer Science and Engineering, CMAT, I extend a warm welcome to Mr. Raghu Raman A V and invite him to take over the section. Over to you, sir.
Hey, thank you. Thanks a lot. Just give me 1 second. I hope all of you can see me and hear me well. Okay. So my name is Raghu Raman. You can just call me Raghu. And today's topic we have in hand is data engineering with respect to intelligent infrastructure, right? Now, before getting started, let me quickly introduce myself. I will not take much time, but I think there may be many people who are not aware of my background. So I'll do a quick intro, and then I will give you an idea about the session plan, what we will be covering, and then we will get started with this. So let me share my screen real quick. 1 second, entire screen share. So I have shared my screen. And I hope all of you are able to see my screen as well. Okay, great. So my name is Raghu, and like said in my introduction, currently I'm working as an independent consultant and a trainer. So I have around 20 years of experience in IT. I started my first job probably back in 2006. So this is my 20th anniversary, so to speak. So in 2006 and all, when I started, I think many of you can relate with me. The world was totally different, right? We didn't had machine learning or AI or smartphones even or social media. None of this was there. So from 2006 till 2010, I was working with a company and I was working as a Java developer. And it was in 2010 that I switched to another company where we started working on something called big data. Big data. So one of my primary skill sets or fortes is actually big data. So I started working with big data from 2010 onwards, and now it is 2026, right? So probably for the past, I don't know, 15, 16 years, I have been into big data analytics and projects related to big data. So from 2010 till 2016 or 2015, I was working full time. And in 2015, I quit my full-time job. So I'm kind of like jobless for past 10 years, I should say. I work on a freelance basis. I don't work full-time anywhere. So most of my time, either I spend on consulting, freelance consulting, or on top of like trainings. So I do train people from universities. I also design curriculum for some of the universities. For example, I don't know how many of you are aware of this. We have this university called Ashoka University in Delhi. So Ashoka is one of the top tier premium institutes in India. They are an independent university. So currently I'm working with Ashoka to develop their full semester on data engineering and big data, right? So sometimes I spend, on curriculum development, sometimes on training, sometimes on consulting, and most of the time jobless. Anyway, so that's about myself. So apart from big data, now the topic for today is data engineering. But that is closely related to big data as well. And since we have only limited time, so the duration for the session is, I think, around 90 minutes. What I will try to do is I will try to deliver my lecture till around 1:30 probably, 1:25, 1:30. And then we can pick up some questions as well, right? In case if you have any questions, you can ask me and I will be glad to answer that. And since it is a short session and also big data and data engineering is a very comprehensive field, it is very difficult to come up with a demo for such a short session. See, data engineering demos are actually very complex. It takes a lot of infrastructure setup. And with such a short span of time, I may not be doing justice to the topic if I try to do a demo. So there won't be any demos, but what I would like to do is I like to introduce this terms like big data and data engineering to you. Maybe some of you are already aware of them. Some of you have more experience than me, but I'll try to explain these terminologies with you. And also, I would like to talk about a couple of case studies related to big data and data engineering and how in the industry companies might be using them. So apart from the academic knowledge, right, it is important to have an understanding about how these tools and technologies are being used in the industry. So I will try to explain a couple of case studies. Some of them I have personally worked, some of them I am aware of, so that you will also get an idea about how these tools and technologies are being used. Okay, so let's get started. I have a slide to speak, so to speak. Yes, here is a slide. And we are going to talk about data engineering. The surprising fact that I find is that data engineering is one of the highest paid, most sought after, and the highest in demand topic around the world right now. But very few people are aware of this. I don't know why, because people always talk about job market, and whenever a discussion on job market comes up, the common discussion is like, okay, AI is everywhere. You have to learn AI. You have to learn generative AI, agentic AI. But I don't see anybody talking about data engineering, which is a surprise to me. Because to be frank with you, data engineering has more scope than AI. Now, that's a very bold statement to make, but I stick with my statement. So it has more openings, more demand than AI. But very few people are talking about data engineering. So that is another reason I wanted to talk about this. Okay. So building the pipeline behind modern intelligence. So that's what we are going to talk about. So how is the session arranged? So first, we are going to talk about the foundation of data engineering. So what is data engineering? Before we understand it, we need to understand the foundation of data engineering, which are two technologies. One is big data. The second is cloud computing. Without big data analytics and cloud computing, you will not be able to discuss about data engineering. So first, we will have a brief overview about it. And the second part is what exactly is data engineering and how is it different? Because we know there are a lot of roles in the industry, for example, data scientist, AI specialist, or data, machine learning specialist. So what are the roles related to data engineering and how is it different from the typical roles that we usually see? So that is the second part. The third part is where we discuss what we call an anatomy of a pipeline. So end of the day, I'll come to this topic, but end of the day, when we say that we are working on data engineering, what we really do is we are building something called a pipeline, which will move the data from source to destination. So end of the day, data engineering is all about building pipelines, which moves data from one place to another place. So the anatomy of a pipeline, why do you want to build a pipeline? And what are the different types of pipeline? For example, we have batch pipelines, streaming pipelines, and then there is something called ETL, ELT. So these kind of topics, I would like to have a quick discussion about it. Then we'll talk about some industry use cases. So there are four real case studies we'll touch upon. So we'll talk about how Uber is leveraging data engineering, how Netflix builds smarter pipelines to move their data, and a word about how Airbnb and Spotify works with data as well. Then the fifth will be where the field is heading. With the invention of AI and other new age technologies, what are some of the latest trends in data engineering? So we have topics like Lakehouse and RAGs and vector DB. So I'll try to cover a basic idea about them, and then we can have a discussion and takeaways. So I'll probably keep some time for discussions, and I don't know if I will be able to answer all your questions. That's another thing, but I will try my level best in case if you have any questions. So this is what we are going to do, starting with what is big data. Now, big data is not a very trending topic today. So we are in 2026. And if I ask somebody about big data, even students or even working professionals, everybody is aware of big data. It's not a groundbreaking technology or something today. But there was a time when big data was considered very new and very challenging. So I'm talking about 2006 till 2010. So what do you really mean by big data? So the term says big data. So obviously it has to be big, right? Now, big data is a term that we created to identify data sets which cannot be handled by traditional systems. Now, if you look at a traditional IT company, right, what do? They collect data. Any company which would like to grow, which would like to make some profit, they depend on data. I don't have to tell this to you, right? So every company's motive is collect data. Now, you look at a company like Flipkart, for example. So I was working with Flipkart in 2018 and 2019, the company called Flipkart, right? E-commerce vendor, right? So when I was working with Flipkart, I'm probably I can just use a notepad to talk about this. Just give me 1 second. Sorry. Yeah. So when I was working with Flipkart, what we observed is how Flipkart is probably working with our data, right? So one thing we realized is that on an average, Flipkart collects around 40 to, I would say, 50 terabyte of data per day. So every day they used to collect 40 or 50 terabyte of data from users, right? Now I'm talking about a daily data, not even monthly, right? So this is huge amount of data. So this is one of the problems we call it as volume or size of data, right? The second thing that we noticed is that Flipkart is actually collecting different type of data. Now, they are not interested in only one kind of data. They are interested in multiple kinds of data. For example, they collect social media data. They want to know which products are trending in the market and which city, which users are searching for what kind of products. So they constantly gather data from Twitter or X, then Facebook, then YouTube comments, news media articles. So social media data they collect a lot. Log files they collect a lot. So when I say log files, what happens is, let us say you open your mobile phone and then start browsing Flipkart, right? What happens is the data from your app is collected in the form of what we call log files. So the log files will contain information like what time of the day you logged onto Flipkart, how much time you spent on Flipkart, what items you clicked, how much time you spent on checkout, what is the model of your mobile phone, all the data. So they used to also collect log files. They also used to collect transactions. They had logistics data. So the first problem related to Flipkart's data analysis is that they have huge amount of data, the volume, right? The size of data. I mean, think about it, right? If I'm giving you 50 terabyte of data every day, where will you store? Now, you may argue saying like, I will store it in a hard disk or I'll store it in a database or somewhere, but you have to also consider the cost aspect of things. A company like Flipkart, they cannot spend a lot of money for storage. So how do you store massive amount of data, which keeps on coming every day at a very cheap rate? So that was the problem we call the volume problem, the size of data. The second problem we call is the variety problem. So this is the variety problem. You see, if I am Flipkart, if I am getting some data, imagine I'm getting 40 terabyte of data, I can somehow store the data. Forget about how I'm storing the data, but somehow maybe I will be able to store the data. But the problem is, why are you storing the data? Because you want to come back and analyze the data, right? That is why you're storing the data. Now, if I'm storing only structured data, let us say the data that you find in databases and all, it is easy for me. I can have a MySQL database or any database and dump all my data. And I can analyze it using SQL queries or whatnot. But the problem with Flipkart is variety. Some of the data is social media data, some of them are log files, some of them are transactions, logistics data, ERP data. So it is a mixture of different type of data. That is what we call the variety problem. So how do you analyze all this data, which is in terabytes, coming daily on terabytes, which is also having different file formats, and how do you make sense? The third problem that we call is actually called velocity. Velocity. Velocity is the speed of data. Speed of data. That means for a company like Flipkart, every second or every minute, they are constantly hit by data because millions of people browse their app or website or whatever you call, not only Flipkart, Amazon, or any of these kind of companies. So handling all this is what we call the big data problem. So usually we say big data is a problem. So back in 2006 to 2010, all the companies in the world were battling this problem because the internet was very new and internet was expanding. More and more users were started using services, and every company started facing this big data problem, right? So that is one thing. And then we realized there are solutions to big data and developed a lot of platforms to handle and analyze big data. That is another part of it. But I just wanted to talk about what is big data briefly. Where is the slide, by the way? 1 second. Yeah. So you can see here volume, velocity, variety, and some people even say there is like veracity and value. So these are the features of big data. Volume means, so typically a company, which is dealing with big data, take an example of somebody like Flipkart, they will have around petabytes of data in their storage. 1 petabyte is 1,000 terabytes. So imagine what will be the total size. Now, velocity is the data arrives continuously. So you don't have time to make decisions in big data. So in big data analytics, another huge problem is you don't have time to make decisions. For example, I'll give you a real example. So let us say that you're conducting a big billion day sale in Flipkart. So you go to Flipkart and you're conducting a sale, right? So Flipkart says, okay, you know what? Tomorrow we are having a sale and we are giving like 20% offer on all iPhones. As an example, I'm saying, okay? So the offer says you will have 20% off on all iPhones, right? But the problem is tomorrow when people log on to Flipkart, they start buying products, you realize that they're not buying iPhones. Your offer says 20% off on iPhones, but the people are not interested in iPhones. So let's say they're buying OnePlus or some other brand. So what you need to do is you need to realize this, and in real time, you have to come up with an offer for OnePlus. So this is the velocity problem because the speed at which data is hitting you, you don't have time to make a decision. So that is what you call velocity. And variety is you have different type of data. You have tables, text data, images, sensor data, different kind of data, all kind of data coming at once. So this is called the big data problem. Now, so how did we solve the big data problem? One of the primary ways to solve the big data problem is cloud computing. Now, I don't know how many of you are aware of cloud computing. Some of you might be. So what exactly is cloud computing? Cloud computing is very simple. Cloud computing is just renting services. Think about it like this, right? So let us say you want to buy a car. I want to buy a car. Now, if I want to buy a car, first of all, I have to pay a lot of money, right? Of course, the car will cost me money, right? I don't know, maybe 10 lakhs or 15 lakhs, whatever. So I have to pay a lot of money. Then I have to wait because there is a delivery time. Maybe I will get the car in 3 months and 6 months. And once I buy the car, I am limited to the car. In the sense, I buy a car. Now, there are 4 people who can get into the car. If there are 8 people, I cannot do anything. So IT infrastructure is also very similar. Before 2010, what people used to do is if they want to develop any application. So let us say I am a company, I want to host a website. What I used to do before 2010 is that I used to buy everything inside my company. I will buy servers, I will buy databases, I will buy storage, I will do networking, everything I will do inside my company. So this is like buying a car. It is good you own the car, but the problem is you are stuck with the car. Like you are a company, you want to host a website, you buy server, database, storage, everything. So the first challenge will be you have to invest a lot of money. You have to invest a lot of money because all these servers and database, they are not free. You have to pay money, right? Second thing is, imagine you created some sort of an infrastructure and you hosted your website in your company. Now, what if a lot of people start visiting your website? Then your website will become slow. So now you want to expand your infrastructure, which is not possible because again, you have to buy 3 more servers, add them. That takes time. So in the modern day, what people do is they prefer cloud computing. Now, cloud computing is a service offered by many vendors. Globally, if you look at, there are 3 major players who offer cloud computing. So one is what we call Amazon Web Services or AWS, right? So Amazon Web Services is the cloud computing handle of Amazon, the same e-commerce company. The second popular cloud computing provider is Microsoft Azure. So Microsoft's cloud computing handle is called Azure. And the third one is actually called Google Cloud or GCP. So what you can do is if you are an organization, what you can do is you can go to AWS or Amazon Web Services, create an account with them. And then you can rent all the services from Amazon. For example, I may need 7 servers. No problem. You can go to Amazon and ask them to create 7 servers for you. They will create the 7 servers in their data center, but you will be able to access it. Now, the beauty is cloud computing follows the pay as you go model. That means it is just like calling an Uber. So what is the advantage of calling an Uber versus buying a car? So the greatest advantage is with Uber, you have this pay as you go pricing, right? So for Uber, it is like renting a cab. You only pay for what you are using. You took Uber for 5 kilometers, you pay only for 5 kilometers. Same way in cloud computing, you can rent databases, storage, networking, servers, anything you want. And if you're done with it, you can delete it. So you pay only for what you're using. That is cloud computing. And the biggest advantage of using cloud is that it is highly elastic. Elastic in the sense, like I said, maybe you have created a website and you have hosted the website in the cloud. Now, this website is running on, imagine, 10 machines. All of a sudden, a lot of people start visiting your website. From 10 machine, you can expand to 100 machine within 2 minutes. And then you can come back to 10 machine in another 2 minutes. So you can add and remove infrastructure on the fly. So it is highly scalable, dynamically scalable. So that is the reason why people go for cloud. So what happened is, like I said, uh, cloud computing became the infrastructure where big data
After
analytics
rating,
became
scale
possible.
it down. After rating, take all three bottles.
So what happened is, like, initially we had the big data problem. So the big data problem, the primary problem in big data is, where do you store all this data? Now, cloud gives you options. So when you go to cloud, especially like if you go to AWS or Azure, you can get unlimited storage for very cheap price. So cloud solves the, so-called storage problem. The second problem is, how do you analyze big data? Again, cloud provides machines and clusters where you can do big data analytics. So cloud computing became the backend infrastructure, and big data analytics became on top of that, right? So big data analytics is anyway required. That started running on top of that. Using this, companies started building intelligent data pipelines. That's what we call data engineering. So what exactly is data engineering? Data engineering is primarily working with big data on cloud. Now, it is not just you're taking some big data and dumping it on cloud. It is basically starting from collecting the data, storing the data, analyzing the data, and getting some insights. So every company want to do this, right? Every company, the four common stages they want to do is, they want to collect maximum data, and they want to store all this data somewhere, and then they want to analyze this data and get some insights. Now, in the modern day, when we say collect the data, that is big data. Everything is big data. Now, to do this entire process, you need a platform, that is cloud computing. So using cloud computing as the platform, we collect, store, analyze, and get insights from big data. And that whole process is actually called data engineering. Now, I think there is a definition for that as well. So data engineering is the discipline of building systems that make data trustworthy and usable. Now, you may be probably wondering, why is this such a big deal? This is such a big deal because of a factor called value. So when we defined big data, there was one term called value. See, organizations are all behind what we call value. Let me give you an example. So this is a very popular case study, and many of you might have already heard about this. In case if you have not heard about it, it might be interesting. So this company called Walmart, right? The company called Walmart. So what Walmart did, this was long back. I guess all of you know what is Walmart. Where is Walmart? Yeah. Walmart is one of the biggest retail chains in US. Everybody has at least heard about Walmart. Okay. So Walmart was into big data analytics and data engineering and everything. And Walmart wanted to try something. So what Walmart did is they hired an external consultant. So they had a lot of employees and they were doing a lot of data analysis and everything. But what Walmart did, they hired an external consultant, somebody from outside. And then Walmart said, you know what? We have a lot of data. We have big data. We have petabytes and petabytes of data. Can you build a pipeline, or can you do some analysis on our data and tell us something which we do not know? So Walmart already done a lot of analysis on their data. They know very well what is their data, what happens, and so on and so forth. But then Walmart said, okay, you know what? We'll give you a challenge. Take all our data, dig and do some analysis and then tell us something we do not know. So what this person did, he kind of like, did all the analysis and he came up with a very popular theory. I think some of you might have heard about this, and that is called the classic Walmart beer diaper theory. Walmart beer diaper theory. So what is this Walmart beer diaper theory? So this person, he figured out that on Friday evenings, people buy a lot of beer at Walmart. Okay. And Friday evenings, people also buy a lot of diapers. Now, this seems like a very strange combination, right? Beers and diapers. But this is what he found. He found that, okay, people buy a lot of beer, lot of diaper. Why? I don't know. Nobody knows, right? Probably it's a weekend. People want to chill, so they're buying a beer. And maybe they want to keep their babies happy. They're buying a diaper. I don't know. Nobody knows. So the person said, you know what? Here is my insight. You start selling beer and diaper as a package. Now that seems very strange. Who on earth will give an offer, a package where you can buy beer and diaper together, right? But Walmart did. They started a sale announcing like, okay, on Fridays, if you buy beer and diaper together, we'll give you 20% off. And their sales skyrocketed. This is what you call value from the data. Now, if you want to derive something like this, right? If you want to find out something like this, you have to go through this data engineering pipeline, starting by collecting the data, storing the data, analyzing the data, getting the insight. So that is why data engineering is important. Now, I know that there is a lot of machine learning and AI enthusiasts who always say AI is everything. We are all AI, there is nothing else. AI is the best. I totally understand. In fact, I'm not against AI or something. But if you think about it clearly, even artificial intelligence requires data. AI works on data. Right. So who will feed the proper data to AI? Again, the data engineering pipelines, right? So that is why data engineering is very important. Where is the slide, by the way? Okay. So the discipline of building systems that make data trustworthy and useful. Data engineering is the discipline of designing, building, and operating systems that collect, move, store, and prepare data. So analyst, scientist, and ML model can trust and use it. That is data engineering. See, it's not like blindly people collect data, right? So whenever you're collecting data for a company, you should also have an idea what kind of data you're collecting. And even if you collect data, some parts of the data may not be useful. Some of the data will be duplicate. So in data engineering, what we do is we design, build, and operate systems which collect, move, store, and prepare data. So in a way, you can see that from raw data to insights. Starting from raw data to insights, data engineers work with data to make it useful, right? So one of the things that they do is build and maintain pipelines. So what is a pipeline? A pipeline is something which moves the data reliably, right? And data engineers also guarantee trust. So one of the things that data engineers do is they make sure that the data is consistent, there are no duplicates, there are no errors, it is clean. So the data is trustworthy data. And they also design scalable infrastructure, like in the cloud, because data engineering is not a process that you do in a day. It is a continuous process. So they also handle your, backend infrastructure. Now, who are the people who will consume the data? So data engineers are like the silent soldiers who work in the back end and nobody is aware of them. I don't know. Nobody has ever talked to me about a data engineer. Everybody talk about a data scientist, right? So data engineers are like silent soldiers. Nobody know they're working. But once they prepare the data, who are the people who consume the data? Analytics and business intelligence. So business intelligence, you might have heard about Power BI, reporting and so on and so forth. So people who are working on data analytics and business intelligence, they heavily depend on data engineers. Data science, machine learning, AI, these people also depend heavily on data engineering. Now, what is the difference between a data engineer, data scientist, and data analyst? Because this is also important with respect to the roles or job openings that we see in the market. The data engineer, his primary role is to build the pipelines. So he designs and operates infrastructures that moves the data reliably. His responsibility is identify the data sources, make sure the data is collected, make sure it is stored somewhere, clean it properly, and keep it ready in a format that can be easily consumed by the downstream systems like BI or ML or whatever. That is what the data engineer does. And what are some of the commonly used tools that the data engineer uses, right? So I don't know how many of you have heard about these tools. There is a tool called Apache Spark. Apache Spark. So Apache Spark is probably the most popular big data analytics tool right now. So if you are a data engineer, one of the primary skill set that you need is Spark. Then there is a tool called Apache Airflow. Airflow is an orchestration tool. Like if you build a pipeline, then this pipeline has to automatically run, right? So scheduling and automation is handled by this Airflow. Then there is a tool called Kafka, Apache Kafka. Apache Kafka is responsible for real-time data ingestion. An example will be, let us say you are analyzing credit card transactions in real time. Now, somebody has to give you the credit card transactions in real time, right? So the real-time data ingestion part is handled by Kafka, and SQL obviously is required. Now, these are the tools in the front end. They run in the cloud. So that is by default understood. So one of the primary skill set for a data engineer is that he or she should be able to work in the cloud. So cloud is by default there. So I'm not explaining it again. Now, if you are an analyst, you read the dashboards, the business intelligence dashboard. An analyst, he explores historical data to answer business questions and report trends. So if I am a data analyst, the things that I'm interested is why my sales is going down or why customers are returning products which are good. So let's say I'm working for Flipkart, why customers keep on returning products, why there are a lot of order cancellations, which are the top 10 products that I sold last week, right? What is the age-wise buying pattern for customers? So a data analyst, he primarily uses business intelligence tools and reporting tools, and he does something called historical data analysis. He looks at the data collected and start asking questions, right? And the tools are SQL, Tableau, Excel, Looker. These are all tools he can use. And then you have data scientist. I don't think I have to explain. Let me get some water. Okay, 1 second. Sorry. So a data scientist is somebody who build machine learning models, right? So what data scientists usually do is they learn, not they prepare the machine learning models, which will learn from the data and can make predictions. So these people primarily work in the statistics side. The tools they primarily use are languages like Python, scikit-learn, TensorFlow. These are some of the libraries that these people use. You know what is a data scientist, right? I mean, a data scientist is somebody who builds a machine learning model. What is machine learning? Learning from data so that you can find patterns and make predictions. Okay. And this is very important. This is what you call the anatomy of a data pipeline. So I just clarified that a data engineer builds data pipelines. How? What do you mean by a pipeline? So a pipeline primarily has 5 stages, as you can see. Every pipeline in the world typically goes through this. So first will be identifying the data sources. Okay, I want to do some analysis. I need to get my data. Where is my data? So first, a data engineer has to identify data sources. Now, the data can come from databases like RDBMS. It can come from API calls. It can come from logs. It can come from IoT devices like sensors. It can come from many places, applications, NoSQL databases, you name it. So you have to first identify the sources of your data. If you talk about our Flipkart example, the sources of your data may be social media, the Flipkart app, the internal databases they are using, and then you do something called data ingestion. Now, when it comes to data ingestion, there are two types of ingestion. We say batch ingestion and real-time ingestion. I mean, some of the data will be in real time, so we ingest them in real time. Some of the data we move in batches, let's say once in a day, once in 2 days or whatever. So then there is data ingestion, and then data gets stored. In the modern day, whenever you talk about massive or planet scale data storage, it is stored in a place called a data lake. A data lake is a very common term. A lot of people ask me, like, what is a data lake? Simple. A data lake is a storage platform where you can store any kind of data unlimited at a cheaper cost. And all the cloud computing providers offer data lake solution. Think about it like Google Drive, but cheaper and infinite storage. What do you do with Google Drive? You just store your data. But the problem is Google Drive is costly, right? Now, if you go to Amazon, AWS, they have a solution called S3, Amazon S3. S3 is their data lake. Now, if you go to S3, you can store thousands and thousands and thousands of terabytes of data, very cheap, and any kind of data. So in every data engineering pipeline, storage means it will be a data lake. Now, if you go to Azure, they have something called Azure Data Lake. Amazon has S3. Every cloud provider will have one. Now, once your data is stored, then you have to process the data. Now you have to clean the data, pre-process the data, transform the data. People use many tools, primarily Spark, I should say, for this because it is big data, right? And finally, when the data is ready, you serve the data. Serve the data means somebody will consume the data. Who will consume the data? Power BI dashboards, machine learning models, applications, whatnot. So on a very high level, this is how a data engineering pipeline will look like. And you have special tools for each of these stages. Now, I don't want to get into the tool specific details because it'll be boring and also it'll be too complex. But for data ingestion, we have tools, storage, we have tools, processing, we have tools. So we use different tools to build this pipeline. Now, once you design this pipeline, okay, imagine you designed a pipeline. Now, this pipeline has to run, meaning every day you have to collect data, right? So to automate this, we will be using orchestration and scheduling tools. For example, Airflow. One of the most popular orchestration tool is called Apache Airflow, so to speak. And that takes us to batch versus streaming processing, right? When you are building these pipelines, the data engineering pipelines, you build two type of pipelines. One is called a batch pipeline and one is called a streaming pipeline. What is the difference? A batch pipeline runs on a schedule, hourly, nightly, weekly. The streaming pipeline process each event the instant it happens. Now, I can give you a real world example so that it makes sense. So let us say you're working for a bank and your manager says, okay, I want you to generate a report every week as to how many people, let us say, how many people missed their credit card bill last week. See, credit card bills come every day, right? I mean, like different people will be getting different credit card bills on different days, right? So your manager says, you know what? Why don't you generate a report which will tell every Monday how many people did not pay credit card last week? Now you have to create a pipeline for this. But when you create the pipeline, you will collect the data on a weekly basis because your manager is expecting data from last week. So what you probably do is you will build the pipeline, you will have source, ingestion, storage, everything. but you will run the pipeline Sunday evening. So Sunday evening, when you run the pipeline, what will happen? The whole last week of data will be ingested, stored, processed, and it will create a dashboard. So Monday morning, when your manager comes, he will say, okay, these are the people who didn't pay the credit card bill last week. So this is called a batch pipeline. Batch pipeline means the data is collected in a batch mode, daily, weekly, or whatever you call. The same bank tells you, okay, I want you to find out how many, or I want you to figure out credit card fraud. So let us say you are building a data pipeline that is going to detect credit card fraud transactions. So what happens? Let us say I'm using a credit card. Somebody stole my credit card, or somebody, I don't know, impersonated me, whatever, right? So, and somebody started using my credit card, imagine. Now, if you want to find out credit card fraud, you cannot wait. Every transaction has to be analyzed. So if you're building a pipeline which will show you credit card fraud, your ingestion will be real time. Every second you will analyze the data, because there is no point, right? So let's say today, 10 o'clock, somebody stole my credit card, he swiped the card. There is no point in analyzing this data next week and saying that, okay, last week there was a fraud. By the time, all my credit card limit will be exhausted, right? So the real-time pipelines work every second. That is what it is saying. So batch processing means it runs on a schedule, hourly, nightly, weekly. High throughput on large historical volume, historical data, last 1 week, 1 month. High latency, minutes to hours. So batch pipelines will take a lot of time to process your data. The tools that we use for batch pipelines are Spark, Hadoop, dbt, etc. And then we have streaming processing or real-time pipelines. Process each events in the instant it happens. It runs milliseconds to second. Continuous processing. We use Kafka, Flink, Spark streaming, these kind of things for real-time processing. Now, I will come back to this slide if there is time, but let us talk about data engineering in the real world. 4 companies, 4 problems. So let us discuss 4 companies, starting with Uber, Netflix, Airbnb, and Spotify. And let's have a very high level overview, because see, I can talk about each of these companies in depth, but unfortunately, we don't have enough time. So we'll at least try to understand what problems they're facing. Uber. So what is the problem Uber faces? Real-time dynamic pricing. What do you mean by this? I don't know how many of you tried this. I mean, in Uber, so let us say it is a Monday morning, right? Monday morning, 8 o'clock. You are in Bangalore. Well, you can be anywhere. Let's take the example of Bangalore. So what happens? It is Monday morning, it is 8 o'clock, and there is heavy rain. It is monsoon season, right? You try to catch an Uber. Now, chances are very high you will not get the Uber, because a lot of people are looking for cabs. Now, if you get a cab, you will see this thing called surge pricing. Uber will tell you that you have to pay double, triple the price because of the classic supply demand problem, right? Because you have to pay triple. Now, how does Uber come up with this dynamic pricing? Have you ever thought about it? It is very brilliant, because Uber has to match millions of ride and delivery requests with the right driver and get the right price every second worldwide. Look at India alone. How many locations Uber is serving? Millions of locations. So Monday morning, 8 o'clock, Uber has to collect data from all around India. All the riders' data, all the drivers' data, match them, then give the price. And this has to happen in a split second. Don't you think it is intelligent? It is intelligent. So how does this work? So there is this trip event data that Uber uses. So this includes the GPS location, driver request, traffic condition, and weather. So the primary data that Uber takes is your location, that is GPS. Request means you request for a cab, your request data. Using that, it will identify your location, nearest drivers. Then it takes traffic data and weather data. So this will be millions of events. These are streamed through Kafka. So Kafka is your real-time ingestion platform. And then Uber uses a platform called Flink. Flink and Samza, they are used for real-time data analysis. So in real time, within a split second, Flink will run, come up with a pricing, and then this result will be dumped into a database called Cassandra. So Cassandra is a NoSQL database. Don't worry about it. And then Uber has its own machine learning platform called Michelangelo. This machine learning platform looks at Cassandra's data and predict the price that is shown in your app in a second. So imagine this, right? So because the pricing has to be predicted by a machine learning algorithm. So Kafka pushes the events, Flink does real-time analytics of the data, and the results are stored in a NoSQL database called Cassandra. And that is used to, that will feed into Michelangelo. Now, Michelangelo will give a real-time prediction. Okay, Raghu is waiting in Bangalore, Jayanagar 2nd Street. His price is double. That is how it works. So Uber has 5,000 plus machine learning models in production, and their prediction speed is 10 million per second. Every second, 10 million predictions are delivered by Uber. They have 400 plus active machine learning projects company-wide. So again, this is a pipeline built by a machine learning engineer. Why it matters? Price and estimated time of arrival adjust within seconds of demand shifting, balancing rider wait time with driver earning at global scale. So this has to continuously happen because you may cancel a ride, you may choose a different driver, you may choose a different mode of transport. So continuously this has to happen. So this is a real-time pipeline. Second is Netflix. Personalization at scale. So what problem Netflix faces? Make every one of 300 million plus members feel Netflix built a homepage just for them and refresh it the moment their take shifts. So what is the problem here? I don't know how many of you notice this, right? Your Netflix home screen has to be personalized for you. And this has to happen again in real time. So let us say I open Netflix, I try to watch a movie. I don't know, I watch Titanic. I don't know. I hate that movie anyway. So I watch Titanic, half the way, I stop the movie. Now, if I stop the movie, chances are very high I will quit Netflix. They don't want that to happen. They want me to stay on their platform. So Netflix has to figure out, why did I stop watching Titanic? Is it because it is a romantic movie? Is it because it is having Leonardo DiCaprio? Am I a Leonardo DiCaprio hater? Is it because of the time? And then they have to recommend a new movie or series to me in real time. This should be done for 300 million people in real time. So how do they do it? So they have this member event data. Whenever you play something, post something, scroll something, search something, they collect the data. Again, this is ingested through Kafka. And you have Flink, Apache Flink, real-time data processing engine, which analyzes this data. And then they use the NoSQL database called Cassandra, where they profile you actually. There is something called taste profiling. They profile you based on your location, your interest, how much time you watch a movie, you pause a movie, you repeat. They match a profile for you. And they have a machine learning model trained on Spark. Based on that, they refresh your homepage. So every time you stop a movie and go back to your home screen, this entire pipeline runs and you get new recommendations. And what is the scale of this? 300 million plus members worldwide, trillions of events processed daily. They have 20,000 plus Flink jobs in production, right? Now, why it matters? Because fresher recommendation keep members watching longer. If Netflix doesn't recommend anything, people may get bored and like skip it actually. And Netflix recommendations are so good. That is why if you keep on watching Netflix, you will never go back to Amazon Prime. It's not because Amazon Prime is bad or Amazon Prime has bad shows, nothing like that. But when it comes to recommendation, Netflix is far better than Amazon. That is why when people watch Netflix, they stick with Netflix. The third example is Airbnb. Airbnb. You know what is Airbnb? The platform at scale where people can list and rent rooms and houses and whatnot. What is their problem? keep millions of live listing trustworthy and fairly ranked while every team works off same numbers. So the problem with Airbnb is they have to keep their data trustworthy, because when people visit an Airbnb home, right, they generate events. Events means people may book an Airbnb home, they may send messages to the host, they may pay payments to the host, they may post comments about the host. All these are platform events. Now, what Airbnb does, they take this and they have a stream model, right, where they feed this data and they have their internal Star Rock platform, which kind of like does the real-time fraud and policy check and give live alerts detection. So one of the things that they do is real-time fraud detection, right? For example, there may be hosts who are fraud, listing may be bad, the host says there is TV, but there is no TV. So by collecting data in real time, they does this fraud detection, right? What they also do is, you get fair personalized listing. So they collect data from host, they analyze, do searching and pricing for every query, and then give you personalized result, right? So Airbnb is another example for this. And the last example that I have is Spotify. Now, uh, I don't know how many of you use Spotify. Spotify is where you can listen to music, right? What is their challenge? Turn billions of daily listening signals into playlists that feel handpicked for every listener every single week. Spotify, one of the advantages of using Spotify is that they have this fresh playlist for you. I don't know how many of you are aware of this, but Spotify is the number one platform if you need a playlist. I don't know how you people are listening to music. So what I do is I use Apple Music. I also use Spotify, two platforms to listen. And I always find that Spotify is better. So what Spotify does better is that they collect data from their users. Okay, for example, listening events. Whenever you use Spotify, you may play a song, skip a song, like a genre, you add your song to your playlist. So every activity that is called event data, every activity that you do on Spotify, they collect. And these are billions of events. Okay. And they ingest this to a publish subscribe system, PubSub, that is real-time ingestion. And again, they use Flink to analyze your data. And they use something called BigQuery, Google's BigQuery platform, to store listening history at scale. So there was a case study related to Spotify, and Spotify says that they have billions of lines of history, data history. Data history means, what people were listening, and did they skip the song? Did they rewind the song? Did they like the song, etc., etc. Then they train their machine learning models on this data, and that is how they have this Discover Weekly. So every Monday when you open Spotify, you get 30 fresh tracks. And that actually keeps users on their platform. See, the recommendation is a big problem, right? I don't know how many of you are aware of this. I don't know how many of you listen to music on a regular basis. The problem is, see, I like A.R. Rahman. Okay, I keep on listening to A.R. Rahman. But if every Monday I get A.R. Rahman recommendation, I may be happy, but the problem is there may be a lot of other artists which are really good, and Spotify want to promote them also, which are very similar to A.R. Rahman probably. So what Spotify intelligently does is that they keep on giving you a mix of people you love and new artists as well. So their weekly, playlist, fresh music playlist is powered by an intelligent data engineering platform. So they process 1.4 terabytes of data points. They have 38,000 data pipelines inside the company. And why it matters, personalization that once took an analyst weeks now happens automatically, right? And another big reason for this Spotify is that Spotify has a free plan and a paid plan. By creating this curated playlist and other kind of things, they can push users to pay money and convert to a paid plan. So that is another important thing that Plotify does, right? So the common blueprint behind all four, right? So if you look at all these four use cases, you have a source of data, then either there will be a batch layer or real-time layer, there will be a serving layer and an outcome. So since we have discussed a little bit about data engineering, where the field is heading now, what is the future for data engineering? Now, the first trend is what we call the lake house and data mesh. Okay, so there is something called data warehouses in the industry, and there is something called data lakes. Now, a latest trend is combining the data warehouse and data lake, and it is called a lake house. The advantage of a lake house is that it can store any kind of data. At the same time, it allows modifications and running SQL queries on the data as well. So lake houses are one of the trends that we see with respect to data engineering pipelines and industry. The second one is what we call a data mesh. So what is a data mesh? You divide or segment the data related to different what you call domains, right? For example, marketing, payments, logistics. So each domain owns its data and is responsible for the data and make decisions related to the data. The second trend that we see is AI native pipelines, right? So anyway, artificial intelligence is there. And the newest branch of data engineering is feeding the LLM with fresh, relevant context. So you have these LLMs like ChatGPT, Gemini, they are called LLMs, right? Large language models. They require a lot of data, and that data is powered by data engineering pipelines. The difference here is the type of data that you get. For example, it can be PDFs or tickets or manuals or whatever. And the data is stored in something called a vector database. And the LLM search here and feed itself. So the type of data is actually different here. And the third trend that we see is something called data ops, observability, and governance, right? So what do you mean by this is the data engineering pipelines are now monitored, tested, and governed like a production software. Uh, so there is an observability and governance layer. So one of the challenges that we face in data engineering pipeline is that quality of data. Sometimes we compromise on the quality of data, which is not good. So a new trend is like you treat an entire data engineering pipeline like a software. You do testing, you ensure that data quality is there. So that is another trend that we see. And there is a new term called data operations, data ops, right? So according to Gartner, one of the upcoming trend. So Gartner is an agency which looks at trending technologies and everything around the world. So Gartner predicts that there is a 60% demand for data management tasks by 2027, especially related to data operations, right? So pipelines are now CI/CD automated, version controlled, and so you treat an entire data engineering pipeline like a software. So I'm not quite sure whether I have met the expectation for the session because the time that we had was very limited and the topics in my hand were probably very comprehensive. So I kind of like try to include whatever I can. So probably what we will do, there is only probably 5 to 10 minutes left. We can go for a Q&A in case if anybody is interested to ask any questions. I will be glad to answer. Anybody would like to take over, then I am also okay with that as well. Over to the team. Let me stop sharing the screen so that it is easy for me to maybe pick up questions. So in case if you have any doubts or any clarifications from whatever we have covered, please do let me know. Anybody, Shrishma or anybody would like to take over for me and check if there are anything, or you want to specifically direct me to something? I mean, I'm okay with anything.
Yes, Shrishma here. Participants, if you have any questions, you can raise in the chat box.
Okay, so I see a question. Is data quality important and why? Yes, data quality is absolutely important. I mean, there is a term called veracity. Veracity refers to the quality of data. Now, why is it important? Is because if you compromise on your data quality, that will have an impact on your decision making, because whatever data you're collecting, this is the data that goes through the entire pipeline and probably feeds your machine learning model. So if your data quality is compromised, then the machine learning model will be compromised, your predictions will be compromised, the whole process will be compromised. So it is really important to maintain data quality, because otherwise what will happen, your end results will be also having less data quality, right? It will be compromised. So we have to always try to maintain data quality. Yes. Anybody else? No problem. Anyone else has any questions, please let me know in the chat window. Or you can even unmute and ask. So Ishma, I think we no longer have any questions. Maybe you can take over.
Yes, sir. Participants, if you don't have any queries, so we will wind up the session. So then we will wind up.
Please. Okay.
Thank you, sir, for patiently answering all the questions and sharing your valuable insights. We also thank all the participants for their active interaction and participation. With this, we conclude the forenoon section of day 3. The afternoon section will commence at 2 p.m. We request all participants to rejoin on time. Thank you.
Thank you. Thanks a lot.